Coach Stebleton here. Going to bring you the next lesson in the series of lessons in this unit on Lewis dot structures and bonding. The previous lesson that we did, I talked about Lewis dot structures and how to do simple Lewis dot structures around elements. You can look at that unit. It is shared with you. It's also on my YouTube channel. So you'll need to know how to do that in order to do these next couple of lessons also. Okay, so today we're going to focus on ionic compounds or ionic bonding, and that deals with the transfer of electrons from one atom to another. So you can see an example right here, and we'll talk about what these mean and how you're going to get to this. But with this example right here, calcium has 2 valence electrons, so 2 dots. And those dots are transferred to the chlorine atoms. And again, when we do this, the arrows show the transfer of electrons. There's 3 types of compounds that we'll be covering, or 3 types of bonds we'll be covering: ionic, covalent, and metallic. And each of those deals with the electrons and how the electrons are transferred or shared between different atoms. So again, today is the ionic compound lesson. By the time we're done with this, you'll be able to show the Lewis dot structures and how those dots show the transfer of electrons from one atom to another. Just a little review from Chem A. Remember, with ionic compounds, it's between a metal and a nonmetal, or a cation, the positive ion, and an anion, the negative ion. So here's your 2 ions right here. Calcium's the cation. Calcium will become a +2 charge once it loses 2 electrons, and chlorine becomes the -1 charge because it actually accepts or takes an electron to reach that magic number we talked about in Chem A of 8 outer shell electrons, or 8 valence electrons, the octet rule. Okay. So here's a little review from the previous lesson. Remember, when you do Lewis dot structures, it's based on the number of electrons, but it's not based on the total number of electrons. It's based on the outer shell electrons. So nitrogen here has 7 total electrons. 2 of those go in the first energy level, and then the rest of them would go in the second energy level. And those become the valence electrons because they're on the outer shell of the atom. So nitrogen here has 5 valence electrons, and those are the outer shell electrons. So just to review again from the last lesson of how to do the Lewis dot structure, those 5 electrons go around the symbol, and those are the Lewis dots. And remember to go around the clock first and then start pairing up. So 1, 2, 3, 4, and 5. So that'd be the Lewis dot structure for nitrogen. You can see the 5 dots around the symbol right there, giving it the 5 valence electrons, outer shell electrons, or the Lewis dots for nitrogen. Okay, so what I did for this lesson is I added the charges to the periodic table that was on the previous one. So it still has the valence electrons. Those are now color-coded in green. And remember that everything in this group would have 1 valence electron. Everything in this group would have 2 valence electrons. But I also added the charges, which most of you memorized from Chemistry A. But if you didn't, then you can just look on this periodic table right here, and it gives you the charges for the respective groups and families. So everything in group 13 tends to form a +3 charge in a compound. Everything in group 15 tends to form a -3 charge in a compound. Okay, so let's jump into the lesson, and here's what you guys are going to be expected to do for the assignment that you'll turn in back into the Google Classroom. So here's an example of sodium chloride, and there is some review from Chemistry A, but if you didn't remember it, I'll talk about it and go over it. Sodium here has a +1 charge. How do I know that? If I look at the periodic table, sodium right here is in group 1, and at the top of group 1 is +1 charge. Chlorine is part of sodium chloride. Chlorine is in group 17. If you go all the way to the top of it, chlorine has a -1 charge. So going back to this sheet right here, sodium, we put a +1 charge above it, chlorine, a -1. And remember from Chem A, if they have the same charge, or if they have the same number, but opposite charges, plus minus, they cancel out. So if you write the formula for sodium chloride, you would just write NaCl with no subscripts. Again, because +1 and -1 would give you a net charge of 0. So this would be a neutral compound already. Ionic compounds are the transfer of electrons. Again, that's the key word for today. The electrons are going to be shown to be transferred. So I'll show you that with the Lewis dot structures. Here's the Lewis dot for sodium. It just has 1. And how do I know that? Because if you find sodium here and go to the top, it has 1 valence electron. Chlorine has 7 valence electrons. So when I put those around chlorine, I'm going to put them around, I'm going to go around the clock. 1. Let me get my marker back. Okay. 1, 2, 3, 4, 5, 6, and 7. Now, what you want to look at here is any openings here or any chances to give away an electron. And you can just remember this too. The cation, the metal, will give away its electron. That's the electron being transferred. Because once sodium loses this 1 electron, it will have 10, which would give it 2 in the first shell and 8 in the second shell, which would give it that full outer shell. Chlorine currently has 17 electrons. So if it gains 1, if it gets this one from being transferred, it will now have 18. 2 in the first, 8 in the second, and 8 in the third. So a full outer shell. So what they want to do is get to that octet rule. They want to be stable. They want to have that full outer shell. So here's the example, or here's the diagram of this electron being transferred. And it actually is transferred to this opening right here. Okay, I'll erase this and show you that again. Okay, so right here, if you look at this, you're looking for an opening to where it can be transferred. That opening is right here because these are paired up, these are paired up, these are paired up. This one is single. It wants to be paired up. So we're going to take this electron right here and it's going to be transferred. And that's the sodium chloride. When sodium loses its 1 electron, it becomes a +1 charge. When chlorine gains this 1 electron, it becomes a -1 charge. Those opposite charges create this compound, this ionic compound. The compounds form between opposite charges. Okay, here's another example. Magnesium, going back to the periodic table. Magnesium has a +2 charge. And chlorine, we just did, chlorine still has that -1 charge. So here's magnesium chloride. Magnesium, this is again review from Chem A. Magnesium has the +2 charge, chlorine has the -1. Those are going to cross just like we did in chemistry A. Okay, so with the cross, the old crisscross method, this charge becomes the subscript. And remember, you don't ever write a 1 for a subscript. So with these crosses right here, the compound that forms is MgCl2, where this subscript comes from this charge right here. And all that tells you is that we have 2 chlorine atoms. And the Lewis dots will actually show you why we need the 2 chlorine atoms to make it a neutral compound or to balance it out using that 8 valence electron rule. So I'm going to do the dots around these, and I'll go back to the periodic table to show you how to get those dots. Magnesium has 2 valence electrons. So here's the dots for magnesium. Magnesium has 2, 1, 2, and chlorine has 7. Again, if you forgot that, you can go back to this periodic table. Chlorine has 7 valence electrons. So we're going to put 7 around each of these. Go around the clock. 1, 2, 3, 4, 5, 5, 6, and 7, and 7 on this one too. 1, 2, 3, 4, pair them up, 5, 6, and 7. And notice here, magnesium has 2 to give, and that's why it forms that +2 charge. It's losing 2 negatively charged electrons. It has 2 to give. In chlorine, I'll put the circle again. Chlorine has 1 to accept right here, and also 1 to accept right here. So the transfer then is this electron going to this chlorine, and this electron, and this electron right here going to this spot in the chlorine. And now chlorine has that 8 electron full outer shell, and magnesium lost 2, but by losing those 2, it becomes stable, like the noble gas elements. And again, if you want to start out like we did in Chem A and write the formula like this will actually tell you how many chlorines you need and how many magnesiums you need. So this would be the Lewis dots. And you can actually clean it up in a way, but I would accept this also. Just if you can show me that you understand how these electrons are transferred between the 2 atoms, I'll accept this right here as your answer. Okay, one more before I sign the assignment. Here's one, aluminum oxide, aluminum and oxygen. So let's go back actually to find the charges of these. Aluminum right here has a charge of +3, and oxygen has a charge of -2. Okay, again, aluminum, a charge of +3, oxygen, a charge of -2. So I'll go back to that problem. And I'm just going to write it up here. It might be a little messy, but it's a little bit easier for me to, or quicker for me to write it than to print the sticky notes. Okay, so aluminum. Oops, wrong marker. Aluminum, let's go with the pen. Aluminum +3. And oxygen -2. And they are not the same number, so we've got to cross them just like we did in Chem A. Okay, so then your formula would become Al2O3. Al2O3. And that tells you you would have 2 aluminums and 3 oxygens. So let's put the dots around them, the Lewis dots. Aluminum has 3 valence electrons, and oxygen has 6. Again, aluminum right here has 3 valence electrons, oxygen has 6. So we'll put the dots around them. And this would be one of the more difficult types of ionic bonds. Most of the ones you will have to do will just be the cross between 1 or 2 atoms. Okay, so aluminum has 3, So let's put the dots around. 1, 2, 3. And this one also has 3. 1, 2, 3. And oxygen has 6. Go around the clock. 1, 2, 3, 4, and then start pairing up. 5 and 6. And then you can actually go through and do these other two, but I'll show you where the holes are now, and I'll show you how this is actually going to be transferred. So because oxygen has 2 of them that aren't paired up, you can see these are paired right here. These 2 are not. This is a spot to accept one, and this is a spot to accept one. So we're going to take one of these from aluminum and transfer it. Another one from aluminum and transfer it. And notice we still have 4 more dots or 4 more electrons that need to be transferred. And they would actually be transferred to these 2 oxygens here. Because if this oxygen has 2 openings, which it does, this one's going to have 2. 1, 2. And this one is also going to have 2. And there's, oops, 1 and 2. And now it's a neutral charge compound. Aluminum lost 3 electrons. You can see that aluminum transferred these 3. That's why it becomes a +3 charge. And oxygen accepted 2 electrons. That's what gives it the -2 charge. Okay, so the work that you guys will do, there's a couple of pages that I shared and just a couple of problems. It shouldn't be too difficult. And I set up the first one for you. You'll just put the dots around them, and you'll see that it transfers into the open spots pretty easily when you do the number of valence electrons on these 3 lithiums and around this 1 phosphorus. And then 2 more problems, the same thing on this page, just like the examples right here. And then you can also try a couple of these problems right here. I did the first one for you. I did the first one showing the transferring, and then also this is the name of the compound. That's review from Chemistry A. So if you want to try that, you can do that. You should remember they're all going to end in IDE. Drop the ending and change it to IDE. And that's it for showing the Lewis dot transfer of electrons for ionic compounds. I'll share the actual work that you'll turn back in. I'll share that into the Google Classroom. It'll be separate from this little video lesson right here. And again, as always, if you have questions, email me. There's also, if you go to the Wakelet, remember there's different videos that can help you with those. And then I'll also share another YouTube video into the Google Classroom on ionic compounds and Lewis dot structures if you want a little bit different explanation of how this stuff works here if you're not getting it. So that's about it for the ionic compounds and how those electrons are transferred between 2 atoms. We will next go into covalent compounds and the sharing of electrons. That'll be the next lesson. So if you have questions, email me or join me for a Zoom chat. I'll give you information on that. And then make sure you're turning those assignments also back into the Google Classroom. So, and that's about it. So I'll see you next time in the next lesson.